Welcome everybody to 4RGMeets, and I'm taking over from Scott and Beth because they're off. Beth has a birthday party tomorrow, and today she's got her year-end concert, so she can't be here. Thanks for being here, and we are really looking forward to Jeff's topic tonight. But just want to talk a little bit about who 4R Grandchildren is. For those of you who don't know, we just celebrated our 10th anniversary in Peterborough yesterday. And we are a climate action group whose mission is to inspire, inform, and mobilize people to take effective action to combat climate crisis, however hard that might be. And even if you don't have grandchildren, which some of us don't, we're all somebody's grandchild, so everybody's welcome here. And we're all volunteers, so if you want to help, go to 4rg.ca, sign up as a member. So far it doesn't cost you anything. Sign up to receive the monthly newsletter, which also doesn't cost anything. Follow the link to volunteer. Really, that would be wonderful. Sign up for the monthly newsletter. And if you're really feeling flush, follow the link and make a donation to us. That would really help us. Don't feel obliged. And in addition to the website and newsletter, we have a Facebook page, a Facebook group, and an Instagram account, and even a Twitter account. So you can keep abreast of anything we're doing. And if you want to help with any of these online platforms, please give me a call. We could use lots of help there. So tonight, we're going to hear from Geoff Daw, who's going to talk about, he's the chair of our communications committee, member of the governance committee of 4R Grandchildren, and a member of the board of directors. And he's going to talk about his experience with a year of living with a cold climate air source heat pump. And we have Clara Blakelock, who's going to help him in case there's a question in the very unusual case that there might be a question that Geoff can't answer. And if you do have questions during the presentation, please put them into the chat. We'll keep track of that, and we'll go through them when Geoff's done his presentation. But before we start, I'm going to ask Marilyn Freeman, who's a member of the events committee, to offer a land acknowledgement to recognize where we're holding this meeting.
Thanks, Guy. Bonjour, Anine, everybody. As many of you have heard through many land acknowledgements, we are on the traditional territory of the Michisagi-Anishinaabe. This land is associated with the Williams Treaty of 1923 and the Rice Lake Treaty 20 of 1818. The Anishinaabemowin word for place at the end of the rapids, Nogojiwanong, will be familiar to you by now too. And if you're interested in what these treaties actually have to say and the colonizing effect that they had on the Anishinaabe, check out one really good site, which is opergptbo.ca. It's very brief, to the point, very clear. Now here we are in 2023. We've just come through some very smoky, unhealthy days, which are definitely tied to climate change. The Indigenous peoples have a knowledge of stewardship that we sorely need to be working towards climate justice and decolonization. I have a quote, a very recent quote from Leah Stokes, who's a Canadian professor of environmental politics at the University of California, Santa Barbara. May those smoky days be a signal. May this inspire people to do more to chip away at the fossil fuel system through protest, policy change, or purchase of cleaner electric machines. May these days change us. And I'll add, may we strive to work locally and in conjunction with the leaders and elders of Curve Lake, Hiawatha, and Alderville. Miigwech.
Thank you, Marilyn. That's lovely. I love the way everybody puts their own personality and a personal touch into these land acknowledgements. Kim, do you want to say something about the event that we just held Saturday?
Sure, that'd be great. Thanks, Guy, for fitting that in. Hi, I'm Kim, and I've been chairing a 4RG events subcommittee that is organizing nature walks in Peterborough. We had our first walk on Saturday morning. It was open to 4RG members, as well as the Peterborough Field Naturalists. And we were at the South Drumlin Nature Area at Trent University. It's just a beautiful natural spot. So we had great weather, a good turnout, and our walk leaders, shared their knowledge of the natural world, concerns about the impact of climate change on the birds and plants and animal species and their hopes for the future. Drew Monkman and Scott McKinley led the nature walks, and we were so grateful for their humor and expertise. They were amazing. They helped us see many plant species that I would never have known and identify or see 43 different bird species. And Drew used an app called merlin.allaboutbirds.org. And it's just a really interesting app if people are interested. And Beth McKinley led us in mindful nature connection practices. It's also known as forest bathing. And she spoke of, slowing down, of keeping a balance between joy and sorrow, so we're not overwhelmed by challenges. And she shared some practices with us that helped us do that. And I found it very hopeful, very calming. So we're planning our next walk for the fall, and we will be opening it up to the public. So we will be advertising, as we had before, to 4RG members and on the website. So please keep an eye out and stay tuned. Thanks, Guy.
Thanks, Kim. As I said, Scott and Beth are not with us today, Scott and Beth McKinley, but they have been working on a new schedule for the fall for 4RGMeets, and they have maybe 20 or 30 suggestions right now, and we've only got room for 10 meets, so there's no shortage of topics for us to talk about, and we'll hear more about those when they're back in the fall. So stay tuned for news about that, but there will be no meets during the summer. We're going to take July and August off and start up again in September. So now on to Geoff Daw. He's on the top left of my screen. I'm not sure where he is in everybody else's screen, but he's born in Montreal. Good place to grow up. Grew up in Canada and became a Senators fan instead of a Leafs fan instead of a Canadians fan. I just learned that about him yesterday, but he's still okay. Geoff graduated from Trent in 1981 with a BSc in Environmental Science and Biology. Retired in 2021 after a career in information technology, where he spent most of his time as a database administrator and data engineer. After retiring, Geoff and his wife Wendy moved to the Peterborough area and have become involved in several groups, including the Peterborough New Canadian Centre, Lakefield Animal Welfare Society, Fair Vote Canada, and 4Our Grandchildren. There's probably more that didn't make it to this bio. They both enjoy gardening, camping, canoeing, hiking, swimming, biking, social ballroom dancing, curling, and spending time with their pets. And Geoff has a lifelong interest in energy systems, conservation, and efficiency. So without more, I'm going to turn it over to Geoff, and I'm going to see if I can find that mute all button again and mute everybody.
Okay, so as Guy said, we moved here 2 years ago into a new house to us, and we wanted to look at making our new home as efficient as possible and help to reduce our climate impact and carbon footprint. So one of the things that we looked at was a heat pump. I wanted to do this presentation to share our experience with everybody. Okay, so here's our agenda. I'm going to talk briefly about our house and the things that we've done other than the heat pump. I'll also talk a little bit about the Greener Homes program, and that's changed a little bit. A little bit about heat pump technology. I don't want to focus too much on that, but just to give people an idea how heat pumps work, etc., and different types of heat pumps. And then what our installation and cost was, and then what our first year experience was. So last year was our first full winter with the heat pump. And I'll go over some of the economics of it, some of the savings we realized, and then our greenhouse gas reductions, and then talk a little bit about recommendations and considerations if you're looking at a heat pump, because there are some things that we found that are a little bit different than a normal furnace type installation. So as I said, my goals are really to share my experience and help people who are looking at a heat pump to learn from our experiences, look at our greenhouse gas emissions and also potential savings. So just to sort of level set, and people can sort of compare their situation with our home, but it was a custom built home in 1980. It's a bungalow. We have about 1,500 square feet on our main level, plus a finished basement, so equivalent space down there. It's a wood frame construction with brick exterior, which is sort of common type of construction in North America. I guess, throughout the world. We have a couple of things that are a little bit unique about our house. Even though this house was built in the 1980s, we have 6-inch walls, which was a little bit unique for that period. But I think almost as important is that we have offset 2x4 studs on 2x6s, not straight 2x6 studs, which helps to reduce the thermal transmission of heat through the house. So that helps to make it more energy efficient. We also have a southwest northeast orientation, and we only have one window on our north side, but we have many windows on our south side, which gives us, in the wintertime, when we get nice bright sunny days, we get a lot of thermal gain or solar gain, which helps to heat our house. And I included this picture because it kind of shows how that thermal gain, how much impact that has. So I have a little weather station, and this is a picture of it from January 14th, 2022. And you can see in the upper left corner is our internal temperature, inside temperature of almost 25 degrees Celsius. And the outside temperature is -13, and our wind chill was -18. So you can see that that we got quite a bit of thermal gain from the passive solar. So it really can make a difference. And we really see that on those bright, cool winter days. A little bit about our energy systems within our house. Originally, it was an electric furnace. The little development that we're in did not have natural gas. The natural gas pipeline or natural gas lines were installed in the late 1980s. And at some point, they did convert a lot of the energy systems over to natural gas. So when we moved into the house, we'd had a natural gas furnace, which was installed in 2007. We had an air conditioning unit that was installed in 2003. Unfortunately, we have a lot of natural gas usage. One thing I didn't realize is that we have a natural gas clothes dryer. I didn't really discover that till after we moved in. But we also have 2 natural gas fireplaces. We use it for hot water heating, and we also have a natural gas barbecue. And another thing that's quite unique about this home is that we have a 400 amp electrical service, which is also fairly unique and is far more electricity than we need or most people would need. But I gather it's becoming a little more common as people move forward on electrifying a lot of things, and particularly for EVs as well. So our upgrade plan or the plan that we followed was that we wanted to improve our overall energy efficiency of our home. Since our furnace and our air conditioning units were getting towards end of life, we felt that it was a good time to replace them, and we thought a heat pump would be a great way to do that, since it provides both heating and cooling. We wanted to leverage at that time, it was under the Greener Homes program and the Enbridge grant, which provided some grants back to us depending upon what we did. And of course, we wanted to reduce our carbon footprint. So if you look at the Greener Homes program, and it's now changed to the Home Efficiency Rebates Plus program, and it's now administered by Enbridge. It's a fairly straightforward process, but what you have to do is you need to go through what's pre-energy upgrade audit. So you need to engage an energy auditor, and there's lots of different companies around that will do that for you. One company or one group in Peterborough is Green Up, so I would recommend that would be a great first contact. So they will come and look at your house and look at your energy systems, do an evaluation. One of the things they do is an air blower test to your house to see how well sealed your home is. If there's a lot of leakage in your home, air leakage in your home, they'll give you a report. You'll then determine, and it will recommend what upgrades to do. You will then go through your report and decide what upgrades you want to do, and that can include upgrades to insulation, sealing your home, windows, heating, hot water system. as well as installing solar panels. So you decide what you want to do. You do those upgrades. You then do a second audit. So the auditor will come back and validate that you've done all the upgrades that you said you're going to do. And then you submit the info into the Greener Homes program, or I guess in now you're submitting it into the HER Plus program, and then you'll receive your grants back. And they also pay, not only do they give you grants for the upgrades, but they will also give you money towards your energy audits. So these are the energy efficiency upgrades that we completed in our house before we installed our heat pump. So we upgraded our attic installation to R60, which is now the current standard. We did that. We used blown-in cellulose. We did a lot of the air sealing. Now we did that ourselves. It's difficult to find contractors that will do air sealing, but we were able to make approximately 25% improvement. We reduced our what they call the ACH 50 air changes per hour at 50 kilopascals, I believe. We reduced that from 4 to 3, which made our home a little bit tighter, less leakage into the house. We replaced a lot of the old original aluminum frame windows on the main floor with energy efficient low E argon vinyl windows and a sliding door. We also put a storm door on the front, and we also installed a lot of insulating blinds on our windows, particularly on our south side. So now we'll talk a little bit about heat pumps, since we'll look at our heat pump upgrade. So it's interesting. I did a little bit of research, obviously, and the technology for heat pumps dates back into the mid 1700s, which is kind of interesting. And the first refrigeration units were built in the early 1800s. And heat pump technology is using the same technology that everybody has in their home today. So obviously everybody has a refrigerator. A lot of people have air conditioners, or whether it's a full home air conditioner or window air conditioner. So heat pumps are using the same technology as that. They use heat pumps use a refrigerant with a compressor to compress the refrigerant, expansion valves to allow the refrigerant to expand, and then you have heat exchangers on the inside of the home and the outside of the home. What makes heat pumps a heat pump really is a reversing valve, which allows you to change how the heat pump works. So it can move either in a heating cycle, where you're actually taking heat from outside the house and moving it inside the house, and then in the cooling cycle, you're doing the reverse. So you're taking the heat that's inside the house and moving it outside to cool the house. So it's not generating heat directly like burning a fossil fuel such as gas or oil. You're moving heat, and because you're moving it, you can actually have quite high efficiencies. And the heat pumps can be up to 400% or higher efficiency for each unit of energy that you're putting in. You actually can gain up to 4 times that in heat energy. And the efficiency of the heat pumps will drop as the outside temperature goes down. So we'll talk about that a little bit later on. And heat pump technology is being used in more and more places. So we're seeing it in hot water tanks. So there's heat pump hot water tanks that are now available. And in a lot of EVs, the heat pump technology is used for both heating and cooling the car. If you're interested in getting into the really nitty gritty of it, I've got in my last slide a reference of that you can look at. There's obviously some great YouTube videos where they go through this. So you've got a bunch of different types of heat pumps. The most common is what's referred to as an air source heat pump, where you're taking heat and both moving it from the air and to the air. So the air is being used as both a heat source and a heat sink. There's also ground source heat pumps, which is using the ground as both a heat sink and a heat source. Water source, again using water. And then with the air source, what's really changed over the last 10 or 15 years is what they are referring to as cold climate heat pumps. So heat pumps that can actually work down to minus 30 degrees. And in some cases, we're now seeing heat pumps that can go below that and still provide heat fairly efficiently down to super cold temperatures like that. So where our sort of current most efficient natural gas, propane, and oil furnaces are up to 96% efficiency. Electric heat is 100% efficient. Air source heat pumps can be up to 400% plus efficiency depending upon the outside temperature. The ground source heat pumps are probably the most efficient, but because of their high cost, most people, it's just not, the payback period is just too long. But in certain cases, a ground source heat pump could be an option, I guess, particularly in a new build where you're already doing some excavation for your home. Just to look at how the heat pump efficiency changes with the outdoor temperature. This is actually from the guide that I have for my heat pump. And you can see on the left here, I've circled something called COP, which refers to coefficient of performance. So this is the actual efficiency at different heating levels. So you can see at 8 degrees Celsius over on the right-hand side, it's 3.66 is the coefficient of performance. And then as you go into lower temperatures, it goes down. So at minus 15, it's still almost 200% efficient. So you can see again that these are really using energy efficiently and giving you more heat energy than what the electrical energy that you're putting in. So there's lots of manufacturers that have been in the heat pump game for a long time, and others that are also getting in the heat pump game. There's LG, Daikin, which is the world's largest manufacturer of air conditioning, Lennox, Mitsubishi, Danby, etc. There's lots of different vendors in the game, and hopefully more will get in to it and help to improve overall costs and efficiencies. You also have ducted, which is using ductwork within your home, or ductless options. So if you don't have ductwork in your home, or your ductwork can't support a heat pump, then you can look at a ductless option. The other option, which I know Enbridge has been pushing because they want to keep their gas furnaces going, is a hybrid installation. This could be used for people maybe who because it's a lower cost option, or they want to leverage their existing furnace. You can combine a heat pump with a furnace. So in a lot of cases, like an air source heat pump would be efficient down to say minus 15 degrees, and then the furnace would take over after that. So this is typically a lower cost option. You don't have to worry about necessarily doing electrical service upgrades. You can still get grants from the HER Plus program. And in some cases, for older, less efficient homes, it might be a better option. And if you don't have air conditioning, you would get a side benefit of getting cooling as well along with that. A heat pump only option is typically going to be a much higher cost. Likely you're going to need 200 amp service, and you also get grants with this option. So this is what we were looking at. As I said, there's ductless options, which are referred to as what they call mini splits. So you have an outdoor unit and an indoor unit, and typically in a home you're going to have multiple units. And these can be also cold climate and able to work to minus 30 degrees. And still provide heat. So you can see here you've got an outdoor unit, which is sort of a typical air conditioning unit, and the indoor unit is where your heat or cooling would be distributed into the house, and you run refrigerant lines to those two. So the central ducted system, which is what we went with, is similar to a furnace type AC system that you find in a lot of homes that are using a forced air gas or forced air system. So you're leveraging the existing ductwork. You have an outdoor unit, just like a refrigeration or a typical AC unit, and then inside you have a big, what they refer to as an air handler, which is about the size of a furnace, maybe a little bit bigger, and it has a heat exchanger, and it's used to pull the air from inside your house, pass it through the heat exchanger, pick up the heat, and distribute it into your house. So the requirements that we had for our house was that, again, we wanted to reduce our natural gas usage because we want to reduce our carbon footprint. We had a 15-year-old furnace and a 20-year-old AC unit that we wanted to replace. Our basement area tends to be a little bit cooler, so we wanted to try and improve the heating down there. So our HVAC contractor helped us with that. And also, obviously, we wanted to have comfortable heating in our living area where we live. So, we didn't want to have a less cooler option. We also wanted to leverage the Greener Homes program, rebates and loans. So we got the rebates, the grants on that, or the rebates on that. We got 4 different quotes from a number of different local HVAC vendors, HVAC companies. We had a hybrid option with trying to use our existing furnace, but that did not qualify for the Greener Homes program. We looked at a hybrid option with a brand new gas furnace, and then we looked at the heat pump only option using the so-called cold climate air source heat pump. And at the end of it, we chose the Mitsubishi Zuba Central using our existing ductwork, and it's a cold climate air source heat pump. It produces approximately 36,000 BTUs, or British thermal units. And one of the reasons we chose it was because it works down to -30. So it'll still produce heat for you at -30, and we did hit -30 one day this past winter. It also includes an electric resistance heating within it that's built into it. They call it heat strips. But what it allows the unit to do is, once it does get below -30, it switches over to the electric resistance heating to take over and provide you heat when in those really super cold days. So that was the option we went with. I chose, the other reason I chose the Mitsubishi is because they've been in the game for quite a while. I did participate in a couple of other presentations that talked heat pumps, and those people had also gone with Mitsubishis. But I would say that there are a lot of other vendors that are producing very good heat pump equipment that would also be a good selection as well, a good choice as well. So we installed our heat pump in May of 2022. It took them 2 full days to come in and pull out our old equipment and install the new equipment. We had pretty much had 2 guys working for 2 days to do it, and the overall cost was $21,500, and that was before the rebate. So we received $5,600 back in the rebate. So our first year experience, so we had it for last summer for cooling. It worked very well, although we only used it about 5 times. We typically find our house stays fairly cool, and we can keep it cool on those really warm days by closing it up during the day and drawing blinds where we have to. We also are lucky that we have a lot of trees around us, so they provide a lot of cooling as well. But on those really hot, sticky days where it gets a little bit uncomfortable, particularly at night, we did use the cooling function, and it functioned very well. It didn't have any problems. The winter time for 2022 and 23, it also worked well. Didn't have any issues with it. A couple things you need to be aware of with heat pumps, and if you've been looking at heat pumps, you may be aware of this already, is that heat pumps produce warm air as opposed to a much hotter air that a natural gas furnace or a propane furnace or oil furnace would produce. So it's going to run longer. It'll run for, in really cold days, it'll run for hours at a time. And so this produces a little bit of background noise. So if you're used to your furnace being on at a low fan speed, that's what it's going to sound like. So you've got this sort of constant background noise, which for some people is okay. Other people, it might bother a little bit, but you kind of get used to it. It just becomes a background noise. Unlike furnaces that we're typically used to, we don't the recommendation is not to turn it down at night. So you typically set it to a temperature. We leave ours at about 19 degrees Celsius. You set it to that temperature and you just leave it. You don't turn it down at night like you might a furnace. So if you're used to sleeping in a little bit cooler temperatures at night, that's another adjustment that you sort of get used to. We also use our gas fireplace sort of for our living room space heating on colder days, or if we're using that area and we want it to be a little bit warmer, instead of turning our heat pump up, we turn our gas fireplace on. So we're still using natural gas to some degree, right? And overall, I'd say we were very happy with it. We did, as I said, we did hit a very cold night in early February. So we got to -32, and the heat pump performed okay during that time. I know that the resistance heaters came on because I could smell in the middle of the night. I got up and I could smell sort of that burning, I guess, dust smell that you sometimes get when you first turn on your heating equipment. So that I knew that it came on, and I also was watching my electrical consumption quite closely. You can see that on your, if you look on your Hydro One account, you can track your energy usage very easily. So on that particular day, we used 85 kilowatt hours of electricity. So that was our highest by far. And I'll go over some of our energy usage over the year. So before we had our heat pump, our energy usage, electricity usage was typically about 8 to 11 kilowatt hours per day. And again, you can get on your Hydro One account and see your usage over time, which is kind of interesting to watch. So from May to September, we were typically using about 8 to 10 to 11 kilowatt hours. Then after September, it started to go up, and as I said, we hit 85 kilowatt hours per day on that one particular day. Most of the time, it was 30 to 50 kilowatt hours per day. Most of the usage, again, this is sort of confirmed by the Hydro One website. Most of our usage was at night, obviously when the temperature goes down. So during the day, it wasn't used as much. As I said, our coldest day was at -32, and we used 85 kilowatt hours. And our highest month was more than 3 times electricity usage in the previous year. A couple of things that when I calculated how much energy we used this year, I was making maple syrup, and I used a induction burner to heat my maple syrup. And I figured I used about 100 kilowatt hours, 120 kilowatt hours for that. And then we also participated in a Selwyn food cycler in-house composting system, which I figured used another 35 kilowatt hours of energy. So here's our energy usage for 2021-22. The colors changed because we changed from a time of use billing to a tiered system. But you can see when we first moved in, we were using about 400 kilowatt hours, and I think we had an old fridge that we replaced that was a bit of a clunker and was using a lot of energy, as well as we were using the air conditioning unit a little bit more that summer. But you can see that it sort of trended down, and we were typically in the 300 to 350 type of range. And what's interesting with the Hydro One site is that they also show you the average temperature. So there's this dark line here with the numbers on it, showing the average temperature for that month. So this was our energy usage from hydro, or from electricity, from June 2021 to May 2022 when we installed our heat pump. So here's our electricity usage for 2022 to 23. And you can see from June, we were fairly low, 250, a little bit higher in July, through to October when we started using the heat pump with the weather getting cooler. Again, it went higher in November, December. January was our highest month, where we were, I think, almost 1,100 kilowatt hours. And then trended down as we got in February and March, April, and then back to May. So you can see instead of a sort of a flatter line, we have a bigger spike when we're using more electricity in those months. So I went through all the numbers and I estimated that we used approximately 2,600 kilowatt hours for the heat pump. So basically I took our overall kilowatt hours, I subtracted what we had, approximately what we were using on a monthly basis prior to using the heat pump, as well as the extra electricity we use for making maple syrup and the composter. And at about 17 cents per kilowatt hour, that's including the electricity cost and your taxes and the delivery cost minus the rebate that we get from Ontario. So my estimate on the cost for running the heat pump to heat the house was $443. So our gas usage obviously changed quite substantially, and that was obviously one of our goals. So I took our gas usage for 2021, 22 through, and I compared it to 2022 to 23. So the red line, it was our gas usage in 2021 and 22. You can see in the summer months we use about I think just under 30 cubic meters to heat our water, and then in the wintertime it obviously starts to go up. And we were high of just over 250 cubic meters in January and February of 22. And then in comparison, our gas usage was down substantially. So our gas usage was a little bit higher here because we were using our fireplace as well as using our dryer occasionally. So overall, we sort of achieved our goal of reducing our gas usage. So other things you have to think about when you get a heat pump is that when you're looking at a heat pump, is you may need to upgrade your electrical system. If you're on a 100 amp service or I'm not sure if there's many people on a 60 amp service any longer, but if you are at 100 amp or less, then you may need to do an upgrade, in which case that's going to add a fair bit of cost to the overall installation. As I mentioned before, your heat pump just produces warm air as opposed to hot air, so you're going to have that sort of background noise as it runs more frequently. The outdoor unit does produce noise. In our case, it's not a big deal because we don't have neighbors that are close by. A lot of the modern heat pump systems now are very, very quiet. I think ours is rated at 55 decibels when it's on the outdoor unit when it's running. But if you have neighbors that are close by, that may be an issue. But if it's running more in the wintertime than the summertime, that may not be so much of an issue. And again, the recommendation is not to turn the temperature down. You set it and leave it at the temperature that you want. So if you're used to sort of having a colder room at night when you want to sleep, or turning your furnace down, that's not recommended. Another consideration is power outages, and as we all know that with climate change, we're going to face more power outages. We had the derecho last year in May, wasn't at a heating time, but we also had an ice storm this past year. We were fortunate that we didn't have any outages, but in Eastern Ontario and Quebec, they did have substantial outages, and we've had ice storms in the past that have caused substantial outages. So you have to think about that. It would be difficult to run a heat pump system with a generator. You would need a pretty large generator to generate enough power to run your heat pump. But it would be possible. So you might have to think about some other type of backup heat source for your home if you're concerned about significant power outages. Another thing, probably not so much of a concern, but you need to check or at least update your insurance company that you're getting the heat pump. Their big concern is that they don't want your pipes to freeze and your water to burst, or your pipes to burst. So you need to confirm with them or tell them that you're moving to a heat pump. And this was pointed out to me recently, I think from Patricia Morton, about heat pumps that are using refrigerated refrigerants that are actual greenhouse gases, and this is true. You know, and I'll talk about that a little bit more in the next slide. The other concern is existing ductwork. Heat pumps typically like larger ducts, so when you're talking with your HVAC contractor, if you get your HVAC contractor to come in and have a look at your system, you can ask them about the ductwork, or make sure that they check the ductwork to make sure that it's large enough to handle a heat pump, because it's pumping through more air throughout your home. Another consideration is the electricity that's being used. How is it being generated? If it's being generated by a coal-fired power plant, which we don't have in Ontario, or even a gas-fired power plant, the actual impact may not be as great as we hope. So that's something that we have to think of. And finally, the lifespan of a heat pump. You know, because these cold climate systems are a little bit newer, I'm not sure. We don't know how long they're going to last, but my research is showing that they're going to last at least 15 years. And our system has a 10-year warranty on it for the entire unit. So a little bit more about refrigerants. So obviously the refrigerants are really the heart of heat pump and cooling technology. They're the things that are being pushed around and compressed and expanded to generate the heat and the cooling that they're producing. So they're really critical to it. As we know, refrigerants have kind of evolved over time. We had the issues with the ozone layer and CFCs. We moved away from CFCs and went to the hydrochlorinated fluorocarbons, and now we're at the hydrofluorocarbons, and now we're looking at moving away from those because of the high levels of greenhouse warming potential. So sometimes you'll see a number that they refer to as GWP, or greenhouse warming potential. CO2 has a GWP of 1. Some of these refrigerants have GFPs in the thousand. There's one called, I think that should be R143, but anyways, it has a GWP of 4,800. I think methane, or natural gas, has a GWP of 34, I believe. The issue with these refrigerants is, even though they're in your system, if you get a leak in the system, the refrigerants can leak out into the atmosphere, and they can then cause global warming or more warming, because they're greenhouse gases. What they're moving to now are newer refrigerants. Some of them are actually using carbon dioxide, so they're using CO2. Propane is another common one, and isobutane is another one, and these have much lower GWP numbers than what the existing ones are. Our unit is using a refrigerant referred to as R410, and its GWP number is in the thousands. So we need to make sure it doesn't leak out. We purchased, as I mentioned, we purchased a new refrigerator, and it's using a refrigerant called R600A, which is based on isobutane and only has a GWP of about 30. So it's much, much less. And also it doesn't, the amount that it's using is much less. So it's really critical that you keep your heat pump maintained, so that you don't encounter any leakages, or if there are leakages, you get them before they become a bigger problem, right? And if you're purchasing a heat pump, you can ask for manufacturers that are using some of the newer refrigerants, although that might be an issue. I did contact Mitsubishi and ask them, and they said they did not have a time frame yet for when they're going to move to the new refrigerants. But I believe in Europe they're already doing that, so they're a bit ahead of the game. As I mentioned, electricity generation is critical. We want to make sure that we're using electricity that is generated from low carbon sources. So I attended some presentations about our electrical system, and we know it's going to double or triple by 2050. Our demand, because of things like EVs and heat pumps, we know we need to move to a more electric-based energy system. And unfortunately, right now, I believe Ontario is looking at meeting new demand with natural gas, so in the short term, until they can ramp up other things. So when you start to look at the efficiency of a modern gas plant versus the efficiency of a furnace and a heat pump, maybe we're not that much further ahead, unfortunately, if we're using natural gas as our electrical source. That's kind of a critical thing. So I just put in this chart to show a comparison. This was from an IPCC report from 2014. You can see this is the life cycle CO2 equivalent emissions of different electrical generation sources. You can see gas is at 490, whereas solar, hydro, nuclear, and wind is way down at the bottom here, much lower. And in Ontario, fortunately, because we have a lot of hydro and nuclear, and we're moving towards more solar, etc. So what were my savings? What were our savings? So our goal really wasn't to save money, but I mean, I think obviously some economic savings would make a business case for people, make it easier for them to consider this. So our savings were really minimal. Our natural gas is kind of a fluctuating thing. It is regulated, but it did go up and down during the last couple of years. It more so than electricity. So our gas usage from June 2021 to May 2022, when we installed the heat pump, was about 1,270 cubic meters, which cost us about $787. And of that, I estimated that our heating cost was about $630. So if you look at your natural gas bill, you know, it's not a straight cubic meter costs you this much. There's a bunch of other charges on there. It costs you $22 a month just to have natural gas in your home. And then they break it down by the cost of the natural gas plus the delivery costs, etc. So you need to look at your bill a little bit there. And as I said, I estimated our electricity cost for a heat pump was $443. So I estimated that it cost us just under $200 less to use the heat pump versus the natural gas. Now, that said, the 2022-23 winter was warmer than the 2021-22 winter, but we had a lot fewer sunny days. So we weren't getting that solar gain that I showed you earlier. So, you know, whether there's actually a lot of savings there, I'm not sure. Really hard to do an apples to apples comparison, but these are the numbers that I'm estimating. Now, if you look at savings versus propane, oil, or resistance heating, you'll get a lot bigger savings because those things cost more. And I guess I would also say that as we go forward with the carbon tax and as natural gas increases in prices, these savings will sort of go up. So I did a quick estimate about what the savings would be with propane versus oil, and I based upon how much we used to heat our house. We used 24 million BTUs at a cost of about $670, and I estimate with propane it would be 965 liters, and it would cost you $1,215. So you'd get a bigger savings of $770, and then with oil $745. So you would get more savings if you're moving off of oil and propane. So I estimated our CO2 reduction. So we reduced our natural gas usage by 600 cubic meters at 1.9 kilograms per cubic meter. We reduced our greenhouse or our CO2 emissions by just over 1,100 kilograms of CO2. But as I said, our furnace had a little more life in it, so there's some embedded CO2 equivalents in there, plus the source of electricity. Hopefully, it's coming from a low carbon source. So what are the futures for heat pumps? I think that this is going to be a critical technology to get us off of fossil fuels. So in countries that need heating, we need to move to heat pump technology. It's efficient, it's using electricity, and we can generate that electricity with low carbon sources. As I mentioned, the new refrigerants are coming in. We're also seeing better and increased efficiency in heat pump technology. I was just reading about Dicon, who's producing a new refrigerant that they are saying will give them up to 10% more efficiency. In some jurisdictions in the US, they're actually legislating usage of heat pumps, and I think that's true in Vancouver as well. Another thing that's being looked at is central district heating, which would make the use of ground source heat pumps a lot more efficient, or a lot more economically feasible. And I ran into this interesting company called Gradient, which is producing a small window air source heat pump that could be used in apartment buildings, for example. So there's lots of exciting things that are happening there. So here are my recommendations for people that are looking at heat pumps. Obviously, get on board with the Hot Home Efficiency Reduction Plus program. Get a good energy auditor. I was not happy with our energy auditor. Talk to people who have done this and see who they used. I went to GreenUp as my first choice, but unfortunately they were backlogged, so I was not able to use them. But I would say start with GreenUp. I think they would probably do an excellent job. Monitor your energy usage. Everybody, if you're on gas or obviously you're using electricity, you can get on your accounts and see how much you're using. Do your energy efficiency upgrades first. Try and make your home as efficient as possible with those other upgrades, depending upon your age of your house, etc. Consider a heat pump when your HVAC system. So if you're using a furnace today or air conditioner, as those get towards end of life, then that's when it makes the most sense to replace those. Look at your costs. So you may need to upgrade your electrical service if you don't have enough electricity coming into the home. So that would also be a consideration cost-wise. If you want a lower cost system, maybe you can't afford a full-blown heat pump, cold climate heat system, you can look at a hybrid system. So it's a lower cost, but still gives you good benefits, and you get the bonus of the backup heat source. And also the biggest economic benefits, if you're on propane or oil or resistance heating, that's where you're really going to see the biggest benefits and fastest payback. And you can ask about newer heat pumps with the lower better refrigerants, as I mentioned. So in conclusion, I'm saying heat pump technology is efficient and effective. It's something that we need to look at, and people need to move to it when they can, when it makes sense for them. The electricity used has to be low greenhouse gas for the biggest impact. Biggest economic impact is for people moving away from propane and oil and electrical resistance heating. Heat pump costs can be significant. So as I mentioned, our cost, so it is something that is a pretty significant price. So hopefully with more companies getting into the game, we'll see prices come down, we'll see newer technology, and we have to get support from government. So particularly for people that are need economic help, then governments can step in there. District heating where possible. We did meet our goal to reduce our natural gas usage and our greenhouse gas emissions. So that was one of our primary goals, and we met that goal. Our next projects we're looking at are replacing our natural gas water heater with probably a heat pump water system, and also solar modules. The other thing I didn't mention is with the Greener Home programs, you can also get up to a $40,000 interest-free loan that you must pay back over, I think it's payable over a 10-year period. And there's a $10,000 rebate program for people that are on oil, who are moving off of oil. So you can look into those as well. And I put this in at the end, some of the references that I used, as well as links to sites that I thought people would find useful. So that wraps it up. And I guess, Guy, we can open it to questions.
Thanks very much, Geoff. I've actually asked Sharon Hill to give you a specific thanks. She's been paying close attention, and she's going to have something to say. Sharon, can you thank Geoff for us, please?
Geoff, that was a fabulous presentation. It was just so informative and comprehensive, and I can actually endorse it or reinforce it, because I've been through the similar process in the past year, and I wish I'd heard this a year ago, because it just it was so full of all the considerations you have to take into account, from the research to do, to the process, to explaining the technology, which was great. And And I love the parts about, you know, the comparative analysis that you did before and after. Those are really, really helpful. And I really hope that, and the other thing I like too is, you know, the other measures that you did to augment the benefits of a heat pump, you know, things like extra insulation and window blinds and things like that. So there's lots that can be done to your house. And I just really hope that this encourages others to at least investigate it and possibly pursue it. It's not overwhelming, and this is a wonderful resource for proceeding. It really gives you a great guideline for how to proceed. Thank you. It was a wonderful, really comprehensive set of information that I really think should help anybody who wants to proceed with this. It was really great. Thanks.
Thank you.
Thank you, Sharon. And for me, Geoff, this was such a clear presentation that I think we didn't have many people asking questions in the chat, but I imagine that there are some people. I'll go through the 3 comments that were in the chat. One was from Marilyn, who pointed out the same thing that you did in your end slides, which was that there's a story in the National Observer about greenhouse warming potential of some of the refrigerants, and I actually wonder if anybody on this call has done the calculation to see how even if your furnace blew up and all of that stuff escaped, how much more damage that would do, or how much less damage that would do than using a gasoline or methane gas to heat your home. I haven't done the calculation. Right. I imagine somebody has. There's somebody here has a comment. Patrick McCauley said he was curious why there was a problem with sound. So maybe, Patrick, you want to talk about that.
Okay. Yeah, as I mentioned in the comments, a number of my neighbors have installed heat pumps, and they've all commented on how little noise there is, that they're much less noisy than their previous air conditioners. And there was one neighbor, though, who did complain about noise, and a fellow that I've been talking to who's done a lot of research on heat pumps and helped people install them, went to look at this guy's house, and he found that his heat pump is mounted on a bracket attached to the wall, just as his previous air conditioner unit was. And the installer had failed to put in sound dampening pads between the heat pump and the bracket. And the vibration from the heat pump was making all kinds of noise, which was transmitted right through the wall, and happened to be the wall of their bedroom. So they found it quite noisy. But that's something that could be fixed. And as I said, most people found it wasn't noisy at all.
Yeah, I'll have to say our outdoor unit is very, very quiet. When it's running, unless you're within about 10 or 15 feet of it, you don't even know that it's going. The internal noise, I do notice, because in the wintertime, when we're using it mostly, it'll be running for hours at a time when it's cooler out, and you do notice that sort of background noise, and you sort of notice it more when it switches off. It's sort of one of those background white noise types of things. But the outdoor, again, depending upon how close your neighbors are, it may, I don't think it's a big issue, but it may be an issue for some of your neighbors. But I just thought I would mention that. But I agree with you. Generally, they're very, very quiet.
So anybody else who has a question, put your virtual hand up with the reactions. Meanwhile, I'm going to ask a question, or make a comment, Geoff, which is that I've just completed the upgrade of my service entrance from 100 to 200 amps here in Selwyn, and the cost was, well, I haven't got the bill yet, but the estimate was $300 from Hydro to do the upgrade, and it's going to be about $2,000 for the electrician to do that. So you say it's a big amount of money, but it's like maybe an extra 10% on top of the cost of the heat pump itself. Yeah. Oh, Clara.
Hi. Yeah, I just wanted to say hi to everyone and thank Geoff for a great, really comprehensive presentation. I did think of one other thing that I'm one of the energy advisors at Green Up, but I also have a heat pump in my house. And one thing that I had to do, or I didn't have to, but just another consideration is sometimes they need a roof over them. the heat pumps, the outdoor units, depending on where it's located. And I've heard this from other people. Also depends on the design. Some of the outdoor units are designed more like a traditional air conditioner. Mine is more vertical, like yours, with the fan going out. But if they're the sort of air conditioner model, sometimes you do need to build or have built a roof to stop the snow from piling up on top of it. So that's just another thing to think about in terms of the location of where the outdoor unit is going to go. But I've been super happy with my cold climate heat pump, even though my house is older and I'm still working on improving the building envelope. But I've also had similar results in lowering my GHG emissions.
Good.
Thanks, Clara. Sheila.
Yeah, I'm wondering about the indoor noise factor. Is there some website where I can find the one that I'm contemplating is, I think it's Fujitsu. It's not Mitsubishi, but it's
yeah.
Fujitsu. Yeah. If I can get a comparison of the different, this is semi-split, whatever it's called.
Right. So I'm assuming you have a furnace, a natural gas furnace, or some type of forced air furnace today.
Yes, I do.
And does it have a low fan setting?
I think so.
So that would be what it would be like most of the time. So if you run your furnace on a low fan setting, that's pretty much the noise that you're going to get inside. It's just going to run at that low fan setting, but it will run for hours on end. I find that I'm sensitive to that type of noise. My wife is less so, but even at nighttime, I notice when it's running just in the background. Like I said, I'm a little bit hypersensitive to it, but for a lot of people, they don't notice it, or it's just sort of mild background noise.
Yeah. Okay. Thank you.
Margaret Slavin has written a question in here, wondering why rebates are just for homes where the homeowner is living, because they should be available to landlords who are renting to other people. Very good point, Clara.
I just said, so they with under the new program for Enbridge customers, they can actually get rebates for heat pumps for properties that are not owner occupied. I mean, I don't know why the federal program isn't like that, but at least for Enbridge customers, they can.
And one of the things, I mean, I'm in the middle of this whole, not in the middle, I'm at the beginning of this whole thing now, and I'm wondering how you go about finding a contractor who you can trust to do this. Because other than talking to other people who are doing this, I have no way of knowing who's reputable, how you can trust the guys, or anything like that. So it's not a question that anybody, I think, on this call can answer, except maybe for Rob Lockhart, who just put his hand up.
Yeah. Hi, folks. I'm in the process of investigating the same kind of heat pumps, and I've gone through 4 contractors already, and I've had mixed reviews. And you ask one question, you get 4 different answers, and it's almost as complicated as buying an electric car, which of course I've already been through. So, but there's certainly a lot to be said for doing your due diligence and also being careful about the kinds of equipment that you might be considering. And one of the things that I've learned recently is that even though Mitsubishi has been leading the pack in terms of their quality of equipment, because their patent apparently ran out recently, many other furnace manufacturers have been able to snag the technology that Mitsubishi developed, and are now able to provide equipment that is hitting the same specifications as the Mitsubishi. And the pricing that we've got is that they're about $8,500 cheaper. Geoff, you were saying that your service cost about $21,000 last year. That same Mitsubishi is now $30,000. So it's gone up that much in 1 year, and I don't know why that is. Whereas the other companies are down into the 21 range where you were last year. So it's a big difference in price for 2023. I would have only learned that. I wouldn't have learned that if I hadn't ask for more quotes and more companies and learn more about it. So
Yeah.
I'm still learning. I got a quote today on a Bosch system. I didn't even know they made furnaces. And I'm also hearing about some to stay away from, and I'm almost afraid to say on this call whether I should mention anything or not. But there are some that are not, they're universally not recommended, and others that are highly recommended. So again, ask your questions carefully about what are the best systems to consider today. It can be different from last year, so that's really important to get into.
Yeah, those are good points. It is a bit of a moving target, unfortunately, but I think there's going to be a lot of innovation, and hopefully with more companies getting into the game, they'll drive the pricing down a little bit more. When I looked at this originally in 2021, and I received a quote for the same system of about $17,000, and I was a little bit shocked because I didn't think it would be that expensive, and I waited a year and it had gone up that much in a year. So yeah, and I guess that's partially with the inflationary things that we're experiencing today, but you do have to do your due diligence. And I think probably for an HVAC contractor, word of mouth, but certainly somebody who's got heat pump experience, which not all of them do, right? Some of them are more into it, and the vendor I chose, or the contractor I chose them specifically because they've been dealing with heat pumps for a while.
Heather.
I was just going to add that I believe, because we had a hybrid air source heat pump put in last December, and because we went through the grant processes, there were only specific contractors that we actually could use.
Right.
Like that pre-qualified. So there was a list. It wasn't that there was just one, but certainly there was only a list of people that you could use. So that sort of narrowed the choices, but then certainly went with someone that, had been doing it for quite some time, and word of mouth, etc.
Yeah. And there is a list and it's a changing list of units that qualify for the grants as well. So I think somebody pointed that out. So, but if you're dealing with somebody who's done it before, and certainly your energy auditor should be aware of that as well.
Clara, are you hearing any people of the customers you're doing audits for talking about increasing prices or anything like that? Or?
I mean, yeah, for sure. Yeah. I think the prices of everything are going up these days. Yeah, I mean, I've seen the same thing. Like the heat pump that I put in a year ago is $3,000 or $4,000 more expensive this year. I mean, I think it's going to go both ways too, though. It's going to, because as they become more popular and more important people are putting them in, and I think in a few years, they probably won't be putting in any air conditioners anymore, that you won't be able to replace your air conditioner with another air conditioner. There will only be heat pumps. So I think the prices will go down again. We're just not quite at the tipping point yet.
Yeah, well, it's a little, as Rob said, it's maybe a little bit like electric vehicles, where the market is just so topsy-turvy right now. Like there doesn't seem to be a relationship between value and cost. It's just, it's crazy. No, it's not crazy, but it feels crazy. If you wait for a year, you might be lucky. Maybe you're not. But anyway,
that's one other comment I would make is that I've seen vastly different quotes, like for heat pumps, thousands of dollars difference for similar units from different companies. So definitely get multiple quotes.
Yeah, and has anybody done the calculation to see what the impact of this radically reduced hydro price that's coming, the overnight price that's coming in November, is that going to make a difference, Geoff, to your choice of which way to run your heat pump, or which way to get billed?
Yeah, well, I think it will a little bit because, as I said, I noticed when I was looking at my hydro use or electricity usage that a lot of it was at nighttime. So for my heat pump anyways, so it may make sense for me to switch to that, back to the time of use billing, particularly with that lower rate in the overnight.
Cool. So I don't see any more questions, but I have another comment that I'd like to make, which is that in here in Selwyn, we're planning to have a kind of an in-person expo, we're calling it now, a demonstration of what people are going to sew, and I'm hoping that Clara will come along and help with that. She said she would. So, but we're going to do something here in Selwyn where we're going to have a couple of manufacturers, a couple of people who are interested in this. Somebody from Clean Air Alliance probably to come by and talk about the savings, and we'll do that. And if everybody on this call will hear about it, I'm sure by the time it happens, it'll be sometime in late October or early November. And there are so many questions that people have that I think we need to hear the answers multiple times. And Geoff, I really thank you for going to the trouble of putting this together, and I'm really glad that I know somebody like you who can do all the detailed analysis, and I can just kind of tag along.
Thanks. I was happy to do it.
Yeah. Okay, everybody. Thanks. We'll see you again at the next 4RG meets in September, the second week of September. Bye for now. Good night.
Good night.
Thanks, Guy. Thanks all.